Please make sure that you have submitted the homework. It looks like this before I start to go over it. There were 3 pages. We did the first 2 problems here together already, so I'm only going to go over number 3, 4, and 5. So for the first problem, we have to make sure that we're using the relationship that 1 mole is equal to 6.02 times 10 to the 23rd atoms. I am going to show the work for both the conversion factor method as well as the cross multiply with 2 fractions equal to each other. So in red on the left, I have the setup for the conversion factor where you have what you are given and you multiply by the conversion factor of 1 mole over 6.02 times 10 to the 23rd atoms. If you do it in that method, you end up doing 1.2 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. And then on the right in blue, I have the 2 fractions that are set equal to each other, and then you cross multiply to solve for the unknown. Either way you do it, I'll show you what the work will look like. You can see that mathematically, you're always going to take 1.2 times 10 to the 23rd, which was your given number of atoms, and you're going to be dividing by 6.02 times 10 to the 23rd. And so your final answer should be 0.199 moles. And if you rounded that to 0.20 moles, that would be acceptable as well. Again, on the next problem, in red, I have the conversion factor method, and in blue, I have the cross multiply where you set the 2 fractions equal to each other. Both ways, you can see that if you start with 0.750 moles of zinc, you're going to take that and multiply it by 6.02 times 10 to the 23rd atoms, and that will tell you the number of atoms that you have. And for that problem, you get 4.515 times 10 to the 23rd atoms. On the last problem on this page, I have it set up. It's exactly the same setup as the previous problem, where you take your moles and multiply by 6.02 times 10 to the 23rd atom. If you cross multiply in blue, you see that the work ends up the same, that X molecules is equal to 0.4 times 6.02 times 10 to the 23rd. And when you put that in your calculator, you get 2.41 times 10 to the 23rd power. Again, on this next page where we do mole to mass conversions, we did number 1 and 2 together already, so I'm only going to go over number 3, 4, and 5. When we are given molar mass or moles and we want to find mass, we have to make sure that we are using this relationship that 1 mole is equal to the molar mass of the material. So for all of these problems, we are going to need to calculate what the molar mass of each of these materials is. So the first thing I've done is I've written the molar masses of each of the different materials that we're going to need to solve these 3 problems. If you're unsure about how to calculate molar mass, please take a look at the video that's posted in yesterday's folder about how to calculate molar mass. And of course, make sure that you've done the practice worksheet on molar mass to practice doing that and so that you get credit for doing that worksheet. So the first thing I want to remind you is that with all of these problems, you always start with what you're given. So notice that that is the first thing that I have written for every single one of my problems. So again, I'm going to do all of these problems, the red one with the conversion factor and the blue with the 2 ratios set equal to each other to cross multiply and solve for the unknown. So on the first problem, no matter whether you use the red method of the conversion factor or the blue method of the cross multiply, no matter what, you end up with having to mathematically calculate 452 divided by 39.948. So for number 3, you get 11.31 moles. On number 4, you can see again, I have set up in red the conversion factor method and in blue the cross multiply and solve. With the conversion factor, you can see that now you've got the conversion factor flipped because we now need moles to cancel and we need to find grams. And so we multiply our 1.26 times 10 to the negative 4th times 60.06. So you get 0.0076 grams. Finally, on number 5, you can again see my setup in both red and blue for the 2 different methods. And I did round up on this one to 225.80 grams. Again, you can always come back to these videos. They are posted so that you can go over and look at my math to see how to solve each of these. And our newest conversion factor is that 1 mole is equal to 22.4 liters. This is going to be used for when we want to solve problems that involve volume, which is going to include gases, because gases are very light, so we look at their volume instead. So for this problem, again, I am going to set it up in both methods so that you can see how to work out both ways. So first, notice how the very first thing I do is write down what I am given, and then I either set it equal to my other ratio or I set up my conversion factor. So on the conversion factor method, I'm going to put 1 mole on the bottom because that's what I have that I'm given and I don't want moles anymore. And I'm going to put 22.4 liters on the top. Now the nice thing about volume is it doesn't matter what the material is. It is always 1 mole of a gas is 22.4 liters. So you can see mathematically that what we're going to do is we're going to take 0.03 times 22.4 in order to solve it. Now, if I do the cross multiply method, you can see that I want to have moles on top. So I'm going to have 1 mole and then 22.4 liters on the bottom. So again, when I cross multiply, I get X is equal to 0.03 times 22.4 liters. And I simply have to multiply to solve for this one. So once you calculate that, you should get 0.672 liters. You can round that to 2 decimal places, 0.672. So again, remember, we're looking at 1 mole is equal to 22.4 liters. And so again, the first step that you always want to do is pick out what you're given and write that down first. So notice 11.2 liters of argon is written in red and blue, depending on which way you do it. 0.05 moles of neon, 1.2 moles of water. So that's what we're always going to start with. Now, so again, remember that if you're using the conversion factor method, you're multiplying a fraction times a fraction. And if you're using the blue conversion factor method, you're setting 2 fractions equal to each other, and then you cross multiply and solve isolating the x. So on the first problem, you can see that I have set up liters on the bottom of my conversion factor so that liters cancels out, so that my answer will be in moles. And when I multiply across those 2 fractions, I end up with 11.2 divided by 22.4. When I have the cross multiply method, you can notice that when I cross multiply, I end up with 22.4x is equal to 11.2. So I need to isolate that x, divide both sides by 22.4 to solve for x, which mathematically is the same as doing the red version. So either way, you get 0.5 moles. On the next problem, you can see that using either method leads to taking 0.05 moles and multiplying by 22.4, and you get 1.12 liters. Please make sure that since it's volume, you label it as liters. And finally, the last one, if you have it set up correctly, you'll have 1.2 times 22.4, and you end up with an answer of 26.88. Again, it's asking for volume, so that's going to be liters. So now that we've gone over the homework, if you're still struggling with that, please take some time to watch the videos this afternoon that were posted in yesterday's folder and make sure that you're doing the practice problems. The next thing I'd like to go over with you is going to be a couple of additional practice problems, which is going to be this moles, grams, molecules practice worksheet. So if you would, pause the video and take a minute to load that into Notability, and I'm going to do some practice problems with you on that. So on the first one, please remember your best bet is to identify what you're given and then identify what it wants you to find. So that then you can kind of figure out what conversion factor, what relationship we're looking at. So for the first problem, you can see that we're always, again, going to start with what we're given. So 3.01 times 10 to the 22nd atoms. And we want to figure out how many moles that would be. So I'm going to go ahead. I am going to do both methods for you. So I'm setting up the cross multiply method with my unknown moles on the bottom. And in terms of the conversion factor method, I'm going to set up my two fractions to multiply. I'm going to go ahead and put atoms on the bottom since I don't want that, and I'm going to put moles on the top. Now we've got to think about what is the relationship that we know between moles and atoms. Well, we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So this is the relationship that we're going to use. So I'm going to put 1 mole on top since that's where my word mole is, and I'm going to put 6.02 times 10 to the 23rd atoms since atoms is on the bottom. So atoms is going to cancel out so that way my answer is in moles. If I go ahead and I do the cross multiply method, I'm going to set this equal to 6.02 times 10 to the 23rd atoms on top, since I have atoms on top left of my equal sign, and I'm going to put 1 mole on the bottom since I have moles on the left on the bottom. For the fraction on my left of my equal sign. So mathematically, we can see the same thing is happening here. If I use the conversion factor method and I multiply across my two fractions, I see that I've got 3.01 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. If I do the cross multiply method, you can see I end up with 6.02 times 10 to the 23rd x, and then equals 3.01 times 10 to the 22nd. So I have to isolate that x there and divide by 6.02 times 10 to the 23rd both sides, so that way then I can isolate that x, and mathematically I end up doing the same thing in my calculator. So take a second, pause it, put that into your calculator, see if you can get the correct answer. And if you do put it in your calculator correctly, you should get 0.05 moles. Don't forget your unit there, okay? So for all these problems, the first thing that you always want to do is write down what you're given. So you can see that I'm just going to go ahead and I'm going to pick out what I'm given first so that then I can work my way from there. Remember, if you use the conversion factor, you're basically multiplying two fractions. But if you use the cross multiply method, you're setting two fractions equal to each other. I always put my known on top and my unknown on the bottom. So go ahead, pause the video for about 3 or 4 minutes here and see if you can work out and set up these problems correctly on your own, and then unpause the video and I'll go through the math for each of these. So on the first one, you can see that either method, mathematically, you end up with taking 4 times 6.02 times 10 to the 23rd molecules. And that is going to get you 2.4 times 10 to the 24th molecules of glucose. On the third problem, you can see that mathematically what ends up happening is that you have to take 1.25 times 10 to the 25th power and divide it by 6.02 times 10 to the 23rd power. And if you did it correctly, you end up with 20.76 moles. And finally, on the last one, you can see that you're going to have to do 0.75 times 6.02 times 10 to the 23rd, and you're going to get 4.52 times 10 to the 23rd atoms. Again, notice for all of these that we're using mole to atom ratios because we're given moles or atoms and we're trying to find moles or atoms. So please notice that for all of these that we were using the same relationship because that's what we were given and that's what we wanted to find. Now I'm going to go straight to the problems that have mole to mass conversions. Now these ones, remember that the relationship that we're going to be using now is that 1 mole is equal to the molar mass of the material. How do I know that? Well, I'm given things like grams or I'm asked to find the mass. So again, identify first what you're given. So I'm given 28 grams or I'm given 5 moles. And of course, identify then what it wants you to find. It wants me to find moles or it wants me to find mass. So if you can identify which you're given and what it is that you need to find, you can realize that, okay, this is the relationship I'm going to need to use. So that does mean we are going to need to find the molar mass of these two materials. So if I want to find the mass of carbon dioxide, remember, we look on the periodic table. Carbon is 12.011. Oxygen is at 16, but we have 2 of them. So we have to put that all together to get the mass of carbon dioxide. So the mass of 1 mole of carbon dioxide is 44.011 grams. We also are going to need the molar mass of iron oxide. So we're going to need to get the mass of iron, and we're going to have to multiply it by 2. We're going to need the mass of oxygen, and we're going to need to multiply that by 3. So we're going to have to do 55.85 times 2 for the molar mass of the iron involved, and then we're going to have to do 16 times 3 for the mass of the oxygen involved. And so we get a molar mass of 159.7 grams. So we're going to be using those to solve these two problems. Again, I will set it up in both ways. So always remember, begin with what you're given. So you can see that both methods, I have started with 28 grams of carbon dioxide, and for the second one, 5 moles of iron oxide. Now with the conversion factor method, I want grams on the bottom because I don't want grams anymore, and I want to know how many moles that is. So my 1 mole is going to go on the top. So I'm going to put that molar mass of 44.01 grams on the bottom. So you can see when we multiply these two fractions, we end up with 28 divided by 44.01. If I do the cross multiply method, I'm going to put 44.01 grams on top and that 1 mole on the bottom. When I cross multiply, I get 44.01x is equal to 28. I divide both sides by 44.01 to isolate my x, and you can see mathematically that both are exactly the same. And so we get 0.64 moles for that answer. Now on the next one, I'm going to flip my conversion factor because I don't want moles, so 1 mole is going to go on the bottom and that molar mass is going to go on the top. So you can see that we have 5 times 159.7. If I do the cross multiply method, I'm going to put 1 mole on the top, and that's going to be equal to the molar mass in grams. And when I cross multiply, you can see again the same mathematical thing happens. So the answer for that, when you put it in, is 798.5 grams of iron oxide. All of the problems for the next set are mole to grams. Again, pick out what you're given. So I'm given grams of argon. I'm given moles. I'm given moles. And then, of course, pick out what you need to find. So I need to find moles, or I need to find grams, or I need to find mass. So with all of these, you can actually kind of lay out for yourself, okay, you are given grams, and you need to get 2 moles. So you're going to use the relationship that 1 mole is equal to the molar mass of a material. On the next one, you are given moles, and it wants you to find out how many grams that is. So again, moles and grams, we're going to use the relationship that 1 mole is equal to the molar mass of the material. And then the next one, we can see that we're given moles, and we want to find grams or a mass. So again, we're using the 1 mole is equal to the molar mass of the material. So pause it here, take a couple minutes, try these 3 problems on your own, and then come back and check the answers with me. So first thing, check your math. Make sure that you have the correct molar masses for each of the materials. Because if you made a mistake with those molar masses, then of course your math calculations are going to be wrong. So you do want to check those molar masses and make sure that you've got those right. So check and see that you got the same thing as I did. If you didn't, check to see if your setup of your math is the same as what I have, or maybe you just put it into the calculator incorrectly. Okay, so I'm not going to go over all the rest of the problems in this worksheet, but I will post an answer key if you want to use them for practice. There is a video in today's folder, and then there's several videos in yesterday's folder for doing all of the different types of conversions. You have the rest of the class period to work on this homework worksheet, which is you only need to do page 1 today. You will notice that most of these problems are all set up with the conversion factor method, where you start with what you're given and you're multiplying times that conversion factor fraction. If you don't like that method, please feel free to simply show your work for the other method over on the side, or even just write over what your work is to solve those problems. But you do need to do all of page 1 and turn that in by class time tomorrow.